Hello everyone and welcome back to the moment of truth. So in this lesson we are going to deploy and test our smart contract. So to deploy it on a virtual machine on Solidity, I'm going to go to this deploy tab, and here at the top, as you can see, I'm using Remix Virtual Machine Cancun. And here, as you can see, we have our contract. So you will see the compiled contracts up here. And since we inherited from this reentry card, you can also see it in here, but we are going to obviously use our Paypool. So before deploying it, I want to change this to Ether. And since it's free, as you can see, we got a lot of it. I'm going to say 12 Ether. So I'm going to pass the value of 12. So it's just like I'm sending some tokens with the transaction. And as you can see here, we have this value. I'm initializing this with a 12 Ether. So I'm going to say deploy. And here, as you can see, we have a new contract instance and we got our functions. If you look at our total balance, as you can see, we got 12 Ether. We are not going to see this in Ether. We are going to see this in Way. So 10 to the power of 18 Way is equal to 1 Ether. And that's why we have this many zeros up here. Let's start with giving some deposit options. So I'm going to give this next address CB2 some deposit options. If I just try to give myself allowance for a deposit, as you will see here, we are going to have an error and it's going to say not owner because we've said is owner in the beginning of this depositor function. So I need to go to this other account, which is the owner. And here I will come and again see a deposit, and now it's going to work fine. And if we check the first address, let's say 0, as you can see, we got CB2. Let's go to CB2 and deposit some Ether. We had 12 Ether in the total balance, and we can also see the owner C4. I want to change this. Let's say I'm going to deposit one more Ether. And here I will come and say deposit. And now if you check it, it's 13. And now I want to give this other account an allowance. So let's copy this, go to the owner, because if you are not the owner, we cannot make the operation. So I'm not going to test everything that we did in the smart contract since it will take a little bit long. But I suggest you go and try it. And if you find any logic error or something like that, please let me know. It would be better if you just provide me the problem with the solution. But I'm also down for just having the problem. Now let's see, it's C4. So we are going to give the allowance. Let's say I want to give 2, and I'm going to put 18 zeros because if I just say 2, it's going to be 2 way. I want to make 2 Ether. So I'm going to put 18 zeros and the address will be this 2DB. So I'm going to say transact. And the moment I give 2 allowance, let's check this total balance again. And as you can see, it's 2 less because in our code, we said that once we give the allowance, if we can find function, yeah, we are decrementing the total balance. And if we check this address on the mapping, as you can see, it have this allowance. Let me check. Not this one, but this one. I'm going to go here and get my allowance. So I'm going to say allow retrieval. Again, if we check this address, as you will see, it has no allowance. And here we have the same balance because we already subtracted from it. Now, if I want to remove the deposit address, then I will go to the C4. First, let's copy this, go here and make sure this was the address CB2. Now I'm going to say remove allowance. And this is the user I want to remove. Not the allowance, I want to remove the depositor. So that's why we get an error. It's nice to say that this address has no allowance. Now say depositor. Oh, we got a problem here. Even though I'm not sure what the problem is, my expectation is that it's about intensive gas we are using and the operations that we are doing. Let's try to correct this because, as you remember, I said this is not a very good way to do it because it would be too expensive just to pop up an address. Even though it's just one address, I think it's a little bit problematic. So let's give a shot for this one. So here, instead of doing all these operations, we are going to say, let's just find the address, index to delete here. And instead of shifting, we are just going to say deposit addresses I is equal to the address 0. Actually, we can even go like this. I will also delete this so it will be less gas intensive. And we are going to get the index and not the address itself. So let's say index here. And here we are going to provide the deposit addresses index. And we are going to say index here and deposit addresses index here. And now let's save and deploy this and see if this was indeed the problem. And here I will come again and say, okay, let's make this the same owner, deploy with one ether. Now we are going to go here and let's copy this. As the owner, I'm going to say a deposit address. Let's check the first deposit address. We got the CB2. And I want to remove deposit address. It's waiting for the index. I will say 0. And now it's address 0. So the problem is solved. Actually, I was expecting a problem with this operation that we were doing, but I didn't thought that it would be just with one address. But I'm glad that we had, so we can see how it's problematic and how we can find an easier solution. And you can use this address 0 for many things, and this means that at this point it will not be usable. So here now this index will be address 0. No one from address 0 will be able to send me something because address 0 is like a dead end. So if you send tokens to address 0, then it means you are burning tokens because those tokens will not be usable again. So now there you have it. And I think that every other function is working just fine, but go ahead and play it a little bit more. As far as I can see, we got everything. We had a problem with removing depositor here, but we quickly updated our code and now it just works as fine. Here we created a smart contract, and if you think about it, I think it's great that with some simple coding, we were able to create a payment system, and you can actually give time and you can actually make this more robust so that it will be more reliable, safer, you can test it, and then you can finally create a system so that people wouldn't, wait for their money. They can see their money is there, their token is there. Once it's time to get paid, they can just retrieve it. Maybe they will have a time stamp on it, so it will automatically be updated for 1 month later so that it can just go like this. If it gets a little bit more complicated, I think it will be a nice tool to transparently pay to the employees. Thank you very much for sticking with me this whole process, and we developed a smart contract together. We tested it on the virtual machine, and in the next video, we are going to actually deploy this to the Scroll Sepolia testnet together. So stay tuned.